In this part of the tutorial, we will create the user interface for the active game feature. Before proceeding, I strongly suggest you watch my video entitled How to Understand Jetpack Compose, a beginner's guide to composables and recomposition. We will be writing many composables and setting up recomposition as well, but that video is made for people who are just getting started with Compose. It explains what a composable is, what recomposition is, and how to avoid doing recomposition the wrong way. And believe me, it is fairly easy to screw up recomposition if you aren't aware of how it works. I will link to this video in the pinned comment below. This video is full of a ton of information, so please take a look at the timestamps in the description box below. Topics include basic widgets such as text, text button, image, icon, spacer, and divider. Layouts such as box, column, row, box with constraints, and my favorite, constraint layout. Simple transition animations to animate between a loading screen, active game, and a complete game. I also show you how to communicate with our presentation logic and our view model using function types and lambda expressions. Before we write the compose code though, I show you how to set up an activity as a container for composables. The process for doing this is almost identical for fragments if you prefer them. I also show you how to write a very simple dependency injection extension function which hides the backend details from the front end. Right-click on the active game package and go to New, Activity, and choose an empty activity. And make sure you uncheck Generate a Layout File. And this activity will be called Active Game Activity. It will be the launcher activity. Now, in case you're wondering why we're using this wizard instead of just creating a class file, the reason is simply that by using the wizard, it will add an entry into the manifest, so we don't have to do that. Just to briefly recap, the purpose of this activity here is as a feature-specific container. Let's start by creating a reference to our active game logic class. Next, let's implement the active game container interface. Going to click on the red and hit Alt-Enter. For show error, we will use the extension function that we created way earlier on in this tutorial. Go ahead and import. Also, in case you're wondering, this is single expression syntax here. It basically just replaces the brackets and return statement with just an equals sign. Next, we'll implement onNewGame click. Now obviously we haven't created new game activity yet, so that will show up as red until we do. We also need to override two more lifecycle methods. Here we'll tell the logic class that everything is ready to go. And then we'll also override onStop. And that will obviously signal the logic class that it's time to cancel things and tear stuff down. Finally, we just need to add a few lines to onCreate. First, we'll create the view model. Now, this is a really important part. What we're going to do next is we're basically going to anchor our composable that we'll be creating in the next part of this tutorial to the activity here. This is also something you can call inside of a fragment. Go ahead and import that. And naturally, we're going to wrap everything in our compose theme. Now, this is a very critically important thing to understand and a very important pattern. So when we create active game screen, we're going to pass in a function type which will serve as our event handler, which is basically my way of saying that is the way in which we will forward the events, the on-click events and stuff like that, that occur in the composable to our presentation logic class. So make sure you pay attention to what I'm saying here, because this is a really important part. Even if you don't use presenters or whatever, function types are an excellent way to handle on-click events, especially if you combine them with the strategy pattern, which we discussed in the previous section. Okay. Now, if you've never seen a function reference, I believe it's called, basically what we're doing here is we are pointing to the on-event function of the logic class. This really is a function reference, so hopefully you can understand what I'm talking about here. We'll also pass in the view model. Now, lastly, we actually need to build our logic class, so what we'll do is we will write that code in an extension function, but what we can do first is just write it here. And that's everything we need to do in our activity. Right-click on Active Game, go to New Package, and this package will be called Build Logic. Right-click on that package and go to New Kotlin File or Class. This is going to be a file, and it's going to be called Build Active Game Logic. If you've been watching my channel or live streams for some time, you'll know that I talk a lot about dependency injection, service locators, and one of the things I say all the time is that in a small application, you really don't need to use a DI container like Hilt, Dagger, whatever. You can use it, but what I always advise for beginners is to write the code that these things generate for you yourself first, so that you understand what these frameworks are doing for you. So that's exactly what we're going to do. We're going to write the kind of thing that these frameworks generate for you. And in a small application, it's actually very simple code to write. And of course, it's going to return active game logic. Okay, let's pause for just one moment here. So in case you're wondering how we get the path to the storage directory that we can use for this application, you can call context.filesdir.path. Finally, our dispatcher. And that's all we need to do. Right click on the active game feature and create a new Kotlin file called active game screen. First, let's create an enum. This enum represents different states which this feature of the user interface can possess. The actual state is held in the view model, but we will see how we can update our composable UI by binding to the view model's function types we created in the previous part of this tutorial. ActiveGameScreen represents the root composable in this hierarchy of composables. It has the responsibility of setting up the core elements of the UI and also animating between them. The event handler function type reference is how we call back to the presentation logic when the user interacts with the application. It must be passed down to any composable which has such interactions. We also pass in the view model, which is how we actually give the data to our UI. In very simple language, whenever we have some kind of data or state, which may change at runtime, we want to wrap that data in a remember delegate. This tells the compose library under the hood to watch for changes and to redraw the UI if a change occurs. Now, mutable transition state is used specifically for animations here, so don't use this everywhere. We will see a more general purpose example of a remembered state later on. Our remember delegate prepares compose for updates, but we also need a way to actually update the value. We do this by binding a lambda expression to one of the function types which our view model possesses. When one of those functions is invoked in the view model, the program automatically jumps to and executes this code within our composable. This is what actually triggers the recomposition. We have a remembered transition state and a way to update that state from the view model. Now we need to set up the transition animations themselves. This is where you can get as creative as you like. In this app, each content state has its own composable associated with it. We animate between them simply by changing the alpha value or transparency. Now, it was showing up as red a moment ago. The way I fixed that was to manually import the compose runtime. So the transition spec tells compose details about what the animation should look like. Essentially, this means we don't have to write our own mathematical instructions, which is great for someone like me who sucks at arithmetic. One option for compose is to use the scaffold composable as a skeleton for your UI. I personally prefer to do this myself since it's not really that difficult and it doesn't hide anything from me. First, we have our app toolbar. Let's go ahead and create that new game icon. These icons come from the Compose material library. I highly recommend you use it. This is how we actually trigger an on-click event. As explained in a previous part of the tutorial, by creating our toolbar icon here and passing it into the app toolbar composable, we make the app toolbar reusable. Below the toolbar, we have the main content of this screen, which can have 3 different states. Each time a recomposition occurs, this when statement will be executed again. The active alpha value will change when the transition animation occurs, thus fading out the previous content state and fading in the new one. Obviously, we'll create these in a moment. And that's it for our root composable. The most complex part of our UI comes from an active Sudoku game. A 9x9 puzzle has 81 different text composables, which is a large number of widgets. The way I went about writing this composable was to think of each part of the Sudoku game as a particular layer or element. Be sure to avoid writing God composables by making usage of helper functions which break down the UI into the smallest reasonable parts. BoxWithConstraints is kind of like a composable wrapper, which gives us information about the height, width, and other measurements. We can use that information within its lambda expression. We need to know the screen width in order to determine how wide and tall the Sudoku board should be. Here we ask for the max width of this constraint layout. Here we ask for the max width of this layout composable, but we need that value to be in density independent pixels, and it needs to be relative to the density of the current screen as well. That's where the 2dp extension function comes in, and it uses the local density to determine that value. The margin of the board also needs to change based on the screen density. I arrived at these values simply by testing the app on various densities using the emulator. Next, we will write a constraint layout, which is a totally awesome way to manage dynamic layouts. Now, in order to constrain composables to each other, we need a way for them to reference each other. This is equivalent to setting IDs for XML views. First we create these references, and you will see how to bind them later on. Let's create a layout container for the puzzle board. Okay, so this is really important. See how we're passing in that reference in the constrain as parameter there? This is how we actually associate a particular composable with a particular reference. This box composable will be associated with the name board. Next, we'll create the Sudoku board itself. Again, the boundary is like the size of the puzzle, so it's either a 4x4 puzzle or a 9x9 puzzle. So boundary would either be 4 or 9. This is supposed to say size. So the offset here is used to evenly distribute the screen real estate for each Sudoku tile and grid line. Here's a way to make a mutable state which is not associated with some kind of transition animation. So this is the more general purpose approach. So the first argument here, viewModel.boardState, can be thought of as the initial value. Never equal policy ensures that even minor changes in the state, like has focus, actually triggers a recomposition. Again, this is how we actually update the value once the view model is updated. As you can see here, again, I'm making usage of lots of helper functions to break things down. Here we render the text fields which represent tiles in the puzzle. They can either be read-only or mutable, thus meaning that we need to render them slightly differently. So here we're saying if the user sets a particular tile to a value of 0, we actually just want to render it as an empty tile. The main idea here is that we're using the X and Y values of each individual tile along with the offset in order to evenly position each tile. So when the user selects a tile, it's going to become focused, and we want to render that tile obviously a little bit different than an unfocused tile. Now we'll render the read-only squares. Next we'll create the board grid. So sqrt is an extension which is actually defined in the computation logic. In retrospect, I probably should have defined that in the common package, but it's pretty obvious what it does. So this function here will draw the grid lines that separate the Sudoku puzzles. To make it more obvious to the user which subgrids are which, we draw different borders to separate the 4x4 or 9x9 subgrids. This is why we're using modulo here. So this will draw both the vertical and the horizontal lines. Okay, so we're jumping back into the game content composable to finish it off. Below our Sudoku board, we have some different icons to indicate the difficulty of the puzzle. Next, we need a layout container for the count up timer. Let's create the timer text composable now. For the default value, it's just empty. Okay, we're back in the game content composable. The last thing we need to do is just add a layout container for the input buttons. Now, we're about to hard code some values in here, and that is kind of bad practice, but the reason is that the Compose team deprecated FlowRow, which I'm still upset about, and it worked perfectly for this situation, and I've been too lazy to implement FlowRow myself. Hey, at least I'm being honest. In case you're wondering, 0.4 and 5.9 will emit a range inclusive of those values. Let's create that composable. Spacer is pretty self-explanatory, it just takes up some space in the layout. Next we have the buttons themselves. This text button wrapper allows us to style a nice looking button instead of just adding on-click on a text composable. Alright, that's it for game content. Now we need to do the game complete content screen, which is obviously when a user finishes a game. So this is basically just two images stacked on top of each other, but we're only going to render one of them if it is actually a new record that the user made. So since we don't actually create the emoji events icon, we can change the color of it using this color filter thing. Pretty handy. Next we have two text composables. And that's it. Congratulations!